there, my name is Professor Xylophone, and is it alright if I ask you a few questions this morning?
I guess so.
Okay, so what is your approximate weight in kilograms?
60-ish.
60 kilograms.
Okay.
Okay, 60 kilograms. And the acceleration of the elevator is 2 meters per second down.
Okay.
Alright, so when the elevator is accelerating downward, how heavy do you feel?
I think I feel a bit lighter.
Lighter? Yeah? Okay, that sounds pretty good.
Okay.
So your mass times the acceleration due to gravity, 9.8, would be about 588 newtons downwards. Exactly. So plugging that into the formula, ma equals fg down plus fa up, 120 equals 588 minus fa, which would be negative 468 equals negative fa.
Okay.
Which means fa is equal to 468
Newtons.
Exactly. So 468 newtons divided by the acceleration due to gravity, 9.8, is equal to approximately 47.8 kilograms. Is that about how heavy you feel?
I guess because it's less than I said it was
Exactly.
initially.
Perfect. So we have our weight. Thank you so much for volunteering with us.
No
and have a good
problem.
day. We'll see you later.
Can I go shop now?
Yeah.
Okay, thanks.
Yeah. Bye.
Bye.
See you around. So.
Hello, ma'am. My name is Professor Glockenspiel, and I'm a physics major.
Okay.
I have a few questions for you. What is your approximate mass in kilograms?
I'd say about 60 kilograms.
All right, our mass is 60 kilograms, and
Okay.
the escalator, it accelerates up at approximately 2.0 meters per second squared.
Sounds about right.
Yeah. Now, when we multiply your mass by the acceleration of 2, we get approximately 120. All right? And when we multiply the acceleration due to gravity times your mass,
Okay.
we get 588 down plus
Yes,
FA up.
580. Yep.
Now, when you're going up, do you feel lighter or heavier?
I'd say I feel heavier.
All right, well, once our assistant over here does some calculations, what do you get?
Okay, so 120 equals negative 588 plus FA. So that's going to mean that 708 equals FA. So you are going to, and then 708 divided by the acceleration due to gravity equals about 72.4 kilograms. Is that approximately how much you feel?
That's kind of how I weigh.
Perfect. Okay, we have our answer.
So, we can conclude from this calculation that you feel heavier.
I do feel
Unless
heavier.
you're going up.
Okay,
All right.
Thank you for your time.
No
We'll
problem.
see you around later.
Have a nice
okay?
day.
Bye.
The escalator.
Hi.
Oh, hi.
I'm a professor at a physics university, and I was wondering if I could ask you a few questions today.
Sure. Okay.
What is your mass?
About 60 kilograms.
60 kilograms?
All right.
Alright.
Okay.
So, considering that this elevator is going at a constant velocity,
Okay.
or it is at rest, then we can assume that ma equals fg plus fa.
Okay, sure.
Therefore, 588 downwards plus force applied will give us our F net. Got that?
Yes, I've written that all down.
Okay.
So, 60 times 0, which is our constant velocity, will give us 0, which equals negative 588 plus the force applied.
Upwards.
Upwards, exactly. And then the 588 will equal our force applied. If
Precisely.
we divide that by the gravitational constant acceleration, then we get 60 kilograms.
Which is
Okay.
right back to where we started.
So that means that if an elevator is moving at constant velocity, I would feel like I weigh the same as I actually do.
That is correct.
Brilliant.
Yes.
Okay.
So your force applied down would be 588.
Okay. Sure.
Yeah.
That's great. Well, I have to leave now, so bye.
Thank you for your
Thank
time,
you.
ma'am.
Okay.
Have a brilliant day.
Okay.
Good morning, everybody. My name is Professor Xylophone, and I'm here today to analyze the equation of acceleration of an elevator going upwards. So this is our equation right here. F net equals ma equals fg down plus fa up. So if the person standing in the elevator is about 60 kilograms, and the acceleration of the elevator is 2 meters per second up. The force of gravity would be the mass times 9.8 meters per second squared, the acceleration due to the Earth. That comes to 588 newtons. And this is the force applied, which is what we were trying to find. So when we work that out, it equals 120 newtons equals 588 plus Fa. So since this unit right here is the acceleration going upward, but this one is going downward, and this one is also going upwards, we have to change this to go down. Up. And since up equals negative down, all we have to do is make it negative. And then all our units are going up. Okay, so now we move everything to one side. See here, 120 plus 588 equals 708 newtons for force applied. Since that is the force, if we divide it by the acceleration due to gravity, 9.8, 708 divided by 9.8 equals 72.24 kilograms. This is the approximate weight the person in the elevator should feel.
Hello, this is Professor Glockenspiel. Now that we have been through the whole situation of the elevator, we are now going to analyze the equation in depth for you guys. Okay, so what was our kilograms? I believe it was what, 60? Okay. Well, we're going to do 60. And the acceleration was 2, right? Yes? Okay. And the force of gravity, as you guys know, will be the mass times the force of gravity, which is 9.8 meters per second squared down. So we will get 588 newtons. Now, since we are finding force applied, we are now going to multiply 60 by 2 to get 120 on this side. And since that is going down, it will be negative. Alright? And on this side, since this is going down, we are just going to bring this down here. So it will be negative 588 newtons. Now that we have these, we are going to solve for Fa. So we add 588 to 120. And we are going to get 468. So we're going to get 460 newtons equals Fa. Now that we have the force applied, we are going to find approximately how heavy you will feel. So we divide by 9.8, which is the force of gravity. And we get approximately 47.75 kilograms. And as I recall from the elevator, that is lighter than we started with, so you shall feel lighter in the elevator. And thank you for your time and have a nice day.
Professor Marumba. Today we will look at acceleration as 0 on an elevator. And so we have 60 kilograms and the acceleration is 0. So 60 times the constant of gravity, which is 9.8, will give us the force of gravity going down, which is 588. And then we are trying to find this variable. So 60 times 0, that gives us nothing. And then this will bring down, plus our force applied. And we will change the direction to go downwards so that they're both equal. And now we can bring this one over to this side. So it would be negative 588 newtons equals negative 465. And now, since they're both negative, it just cancels out. And we can divide this by 9.8 to get kilograms, which is 60. So with this conclusion, we can say that when an elevator is at rest, then you will feel the same weight as you originally started from.